Hi guys, in this video, I'll show you how to start using Fusion 360 for robotics. First, you should create a project. If you haven't used GitHub before, think of it as a repository. This is where all your files are stored. After you have created a project, you can go into the People's folder and add your teammates so you can collaborate on the project together. You cannot edit on the same model at the same time, though. If you're working with the Vex system, you should also import the Vex GitHub parts library by pressing upload and dragging the GitHub parts folder into the box right here. Keep in mind though that Fusion 360 discards any file folder system that the GitHub parts library already provide, so you might need to spend some time to organize them into folders for easier access. 360, the main way to create 3D objects is by extruding a 2D sketch. So first create a sketch on any plane. Under the sketch folder, you can see that you have a variety of 2D shapes to choose from. For instance, right now, I'm going to create a rectangle. After you created the shape, you can determine its sides by pressing D, which stands for dimension. If you click on two edges of the shape, you can drag the dimension down and define it. In this case, I'm going to make it 200 millimeters. The same thing can be done with the other side. After you have the sketch that you want, you can make it a 3D shape by using the extrude command. So under create, extrude, or just press E on your keyboard. Select the shape you want to extrude and define how much you want to extrude by. This is the height of the object. For ROV, this is going to be the main method of creating robot parts, since you can create PVC pipes in this method by sketching two circles of different diameter and then extruding its difference. And also, you can create flat parts that you can cut with the laser cutter. So, like something like acrylic would be a very good fit for this method. Cutting an object functions very much in the same way. I'm going to use a Vex C channel for an example. So first what you do is you create a sketch on the surface of the object you want to cut. Then you create a 2D shape. And use the extrude command again. But this time we will not be creating any new objects in 3D. We will be cutting from existing objects. So when you drag the arrow down, it should automatically turn into cut mode, which is the method we're using today, extrude cut. However, keep in mind, if the object you're trying to cut is linked to an external file, there'll be like a little paperclip here. In that case, you cannot cut. You have to break link first before you can cut. Once you have created a part, you will want to link it to other parts to create a more complex assembly. This is done via joints in Fusion 360. For instance, by pressing J or going under the Assemble menu to select Joint, you can select two geometries to mesh together. In this case, I want this circle to mesh with this one. You might have to flip the object because sometimes Fusion bugs out, and yeah. You can select the joint type here. Rigid locks something in place. Revolute enables it to rotate on one axis. Those are all pretty self-explanatory. You can explore with them as you want. In this case, I'm going to choose Revolute. I'm going to do this 3 more times to create a 4-bar linkage in VEX. See here? The motion, Fusion 360 automatically calculates the motion required by this mechanism, so it does most of the work for you. However, it is not always easy to find a geometry on an object to use with a joint with, such as on the VEX C channel, they do not provide such geometry. I will link a video to show you how to use sketches on these objects to make them compatible with joints. Another interesting note is that you can link joints that are capable of motion together through something called a motion link. This calculates the motion of each joint's effect on each other. So in this case, you can see the gears turning the rack gear on the bottom to shift it from side to side. This is 936A's gear shift mechanism. For the purpose of general robotics, these skills are all that you need as of now. However, when you create these kind of large assemblies like this 936A robot, it might get really laggy, especially if your computer is outdated or it's not powerful enough. So I will also provide some recommendations on working with large assemblies such as these. What I recommend is create a main assembly, which all your parts are going to be put together. This helps you visualize how all the subsystems will work with each other. But when you're actually working on the robot, I recommend working on individual subsystems. This will increase the speed at which your computers are going to process these models and also makes focusing on small details much easier. For instance, the 936A robot is divided into the drivetrain subsystem, the flywheel subsystem, the lift subsystem, and the gearshift subsystem. Something you will use quite often is the versioning capability of Fusion 360. Think of it as the GitHub for 3D models. Each of your robot's versions are going to be saved on the cloud. For instance, as you see here, this is a 9368 bot, and right now it's on version 82. However, I can access all its versions, all the way down to the first version where I only have a couple of C channels. This helps with recovery a lot. Also, if you decide to roll back on some designs, it's always there for you. If you should decide to use a previous version compared to a later version, you can use this button called Up Promote. This will make it the latest version. Thus will make it editable. The versioning system is also very powerful in that it allows references of parts to be much easier. For instance, in the demo I have here, these 4 parts are referencing the individual links I have made, as you can see by this link symbol on their parts in this browser. If you think, for instance, if you think these links are too long and you want to make them shorter, all you have to do is go to the original file for the link, modify the value you want to change. For instance, let me make this 50 instead of 110. And save it. In the files that references these parts, Fusion will tell you that one component is out of date. And if you click on it, it will update it to the newest version without destroying the links. As long as you don't delete the reference points, in this case the circles, the links will not be destroyed. This is a very, very useful feature when you're working with individual subsystems and combining them in a main assembly file. I believe this is all you have to know to get started with robotics in Fusion 360. Have fun designing your robot.